Hello, everybody. Welcome to the first episode of the Operator View webcast, brought to you by Risk360. We are a cybersecurity firm out of Atlanta, Georgia, and Armada is our offensive security suite of services. And this is the first edition episode of the Operator View webcast where we will cover different technical topics, do demos, and just chat about technical topics and going on in the cybersecurity space. Today is all going to be about React2Shell. I'm Nick Swink. I'll be your host. I'm a senior security consultant. And like I said, today is going to be about React2Shell. We'll just get going, and then people can join in. This is intended to be about an hour, so we'll go to about 11 a.m. Eastern, and then we'll kick it off. But React2Shell, there's a couple more pictures supposed to pop up here. Yeah, so hopefully you guys have heard of React2Shell. It caused a huge commotion about 2 months ago, beginning of December. There's a lot of resources out there that were talking about it. It was a huge deal because of the simplicity and severity of the vulnerability, and I guess combined with the widespread usage of React and Next.js. So today I'm going to talk about some background information about React2Shell. We're going to do some demos. I'm going to show some stuff that I hope is a little different than all the other videos and resources about this. So stuff like honeypot activity and different things that security professionals should also be aware of, like fake proof of concepts or proof of concepts with like backdoors in them. So you need to always be checking the code you're running if you see it on GitHub or a trusted site like that. We can dive into the what and when of React2Shell. So the main CVE here, which is the actual vulnerability, was this first one. It's a completely unauthenticated remote code execution vulnerability in React server components. And this secondary CVE was issued to Next.js, which integrates React server components into it. So it's the same bug, it's just in a different framework. And it's I'm assuming it was created because Next.js is also very popular, so it warranted having its own CVE for their integration of React server components. But Next.js and React server components are widely used. So, and if you think about web applications, they're usually exposed by default, and the vulnerability was triggerable over the exposed service, so like over web. We can go over the timeline. So this timeline's from Phoenix Security. I just use their timeline because it's pretty good. And there's some nice visuals here. So interestingly, the React2Shell was reported in a meta bug bounty. So if you're not familiar with bug bounties, it's basically like a web application pen test open to the world a lot of times, or open to private bug bounty hunters. And so this person reported the React2Shell, or it wasn't called that at the time, but reported the bug to Meta's bug bounty as affecting their systems or their web apps. And then Meta realized that it was an actual vulnerability in the React flight protocol itself. So they worked with the React team to come up with a fix. And I guess that was 4 days later, they did a public disclosure with the fix to NPM. And even though they had developed the fix, that doesn't mean that everyone's patching or upgrading the version right away. So it is, I think, the best way to release a critical vulnerability like this is to make it known very publicly so that people have the opportunity to patch and know about it. But it also gives attackers the time to come up with proof of concepts and spray the internet, which is what happened. So it was less than a day later, the first proof of concept was published publicly. And then after that, tons of proof of concepts were published, which, I mean, that's the way this goes always. And in this case, the proof of concept was very simple. It's a simple post request and triggers server-side remote code execution. So very weaponizable vulnerability, and that's what happened. So by December 4th, there was massive scanning and spraying, and then threat actors latched onto it and started utilizing it. So these are some rough numbers from Shodan back from this timeline. So Shodan, not always the most accurate results, but it gives you a good rough estimate of like exposed systems. So these would be web apps either running React, which we're going to get into why not just a React app would be vulnerable, but if you have React server components, then you would be vulnerable. And then all Next.js apps that touched their router component were vulnerable. So we're looking around, a lot of exposed public-facing services. We're going to dive into the actual vulnerability here. But just real quick, I don't think it's paramount that you need to know the ins and out of every single vulnerability that, comes up, unless you're working in like AppSec. But if you're working in offensive security, you really need to know enough to mitigate damage and carry out like a successful attack. If you're working in defense, you need to know enough to defend or detect an intrusion. So React's a front-end framework, right? So how is it getting server-side code execution? Well, React is a front-end framework, but React server components is not. So React server components is like if you've ever created a default React app and then did like npm run deploy or something like that. It's built-in web hosting application. So it is a server-side utility that hosts the front-end React app. Okay, so Next.js uses this React server components or a version of it, a proprietary version, or not proprietary, but they use that flight protocol in their app router. And Next.js is I guess, more like a full stack solution for building a backend and a front end. It just uses React as the front end like templating. So React server components was where this issue was. And it was in their flight protocol, which handles the serialization of values passed to backend server functions, which to my understanding are basically like remote procedure calls. And so the vulnerability was that the deserialization of these values passed from front end to back end for server functions was not properly verifying that there was that the requested key for an object was set, or the requested key was set on an object. So it basically led to a situation where you could do prototype pollution in JavaScript, which is where you reference the proto object of an object. And this gets very JavaScript-y, like, so you can reference the prototype object of an object in JavaScript and reference other parts of the global JavaScript functions, like pull in different things like child process if you go up the chain of the object, and then you can execute code. Like, so if you bring in child process, which was the main POC, was bringing in child process, and then one of the functions in the module child process, exec-sync, and then executing a shell command from there. So at its core, it was unsafe deserialization and in the flight protocol. And the demo time. So I'm going to jump into a VM here, and let's see. Oh, just got to pull up the right screen. All right. So I'm hopping into Kali Linux here. And there's a good POC with a vulnerable React app. So this GitHub repository has a Docker file that essentially just has the vulnerable versions of React. So it pulls in those. It just creates a React app or a Next.js app. And then if we go into that repository and we look at the package.json, I think, so it has those vulnerable versions of Next and React. And that's all that would be needed for this whole app to be vulnerable. The vulnerability has nothing to do with the actual application code. So like nothing to do with the actual front end code here. It's all just in the flight protocol. So to look at this POC, we can just spin up this Docker container. Let's see. I'm going to have to build it, I think. All right. So it should be on port 3000. If we go into it and look. So this is just some information about React2Shell that they've put into this web app here. But again, this could be anything. It's just the vulnerable versions of Next and React. So we'll pull up Burp Suite here, just so we can see the actual request that we need to send that triggers this vulnerability, and we'll see why this was such a critical issue and also how small the POC really is. We'll pull up the integrated browser to make things easier. And this is just so we can see the requests. So we got the request and response. If you never used Burp Suite, it's just a HTTP protocol analyzer. It can mess with the request and responses to the web server. So I'm just going to copy and paste in the POC here. So we'll send it to a repeater, and we will copy in the POC here, and it has to be a post request. Why is that doing that? All right, that was weird. So it has to be a post request, and basically we're sending multi-part form data to the Node.js or the Next.js application, and these headers. So I believe this header is to trigger this request to be handled by the flight protocol on the back end. And basically it defines this JSON in which we reference one of the objects. And you can see that proto buff reference here where we do a bunch of JavaScripty things and reference the protobuf and then pull in the module child process and then execute the method exec_sync, which is just a function for executing shell commands. And in this case, if it's on Linux, we just have ID as the shell command. And all we would have to do is send that post request, and you can see that, and they actually use an error here to throw an error so we can get the output. And you can see we get the output of the ID command on my like Kali host. Or I guess it's not on the Kali host, it's inside the Docker container. So if we do like uname, we get the host name and version. So that's really the bug and the exploitation. And most POCs were just like Python scripts that were creating this POC in Python or creating this web request in Python and then sending it. And a lot of the activity was just checking whether hosts were vulnerable. So they were doing something like echo vuln or something like this. And then they would check in the response request whether it contained that echoed string. Sometimes it would be like MD5 sums and whatnot. So most of the scanners, that's what they were doing. And I set up a honeypot and was watching some of the activity, and that's what the vast majority of them were doing. I think there's a nuclei template that did the same thing. It just kind of actually does the exploit, but it just checks for an echoed string in the response. And if it gets that echoed string in there, then you know it's vulnerable. Yeah, so that's basically a demo of the exploit and the vulnerability. I'll pop back over to the slides here. I don't know if people can post comments in the Twitter, but if you can, I will be able to see them. Okay. So some of the other stuff I wanted to talk about in this webcast that, besides just demonstrating the bug and the exploit, was some of the honeypot activity. So I set up a honeypot, had a few honeypots. One with an actual React2Shell vulnerable app, and then one with just Teapot from Teapot open source project. Most of the stuff I saw was proof of concept scanners, I think, because you never know, like, if it responds with valid echo response, are they going to send a second stage payload? I don't know. So for Teapot, I was just collecting those first exploit attempts. The ones that I did see actual threat activity was like trying to drop a crypto miner. A lot of these are on GitHub, which is kind of ironic, but trying to drop a crypto miner. And then there was one activity I saw trying to drop a remote access tool, which had some signatures on VirusTotal, but not a ton. I guess I should just stay on the Kali Linux box here. So let me jump over to our honeypot. So this is Teapot honeypot. It's a open source project on GitHub. It's pretty good. It just sets up a bunch of fake services, or I guess real services, but on a bunch of different ports, and then collects telemetry into Elastic. And it's not the most convincing honeypot from like an attacker perspective. So if you were probing this machine, you'd pretty easily figure out it's a honeypot. But for collecting like mass scanners and stuff like that, mass scanning activity, it serves the job. Here's some of the services. So these are actually for the admin. And then this, yeah. So these are the honeypot ports. So tons of ports. Maybe you've seen honeypots like this before in Shodan. There's a lot. You can actually separate these into separate machines. So like different machines with different IPs would run just one of these services and then talk back to a main host so that you could have a more realistic looking hosts. But it's pretty easy to just set up the default mode. So that's what I did. These are all cool and stuff, but we're going to look at just some, what do you call it? Like not predefined, but queries. We're going to do queries ourselves. And one of the queries to look for React2Shell would be that exec sync, or that child process. Again, if they're using a different method, then it wouldn't, like, you're not going to see it in this query. But here I'm going to query for just web requests that have child process string in them. And I'm actually going to set this back for 90 days because I had it off for a bit. And it's going to take a while because it has a lot of data in there. And you can see some of the requests here. So this is useful like threat intel just because you can collect how like the actual anatomy of the exploit, what the post request looks like that they're trying. And a lot of these are just doing, so this one was interesting, PowerShell. They're doing some math here and then probably checking the sum or the multiplication outcome in the response. So similar to the echo method, these might all be duplicates. These are doing the same thing with echoing. Trying to find something that's not just echoing output. Here's one. So this one looks like they're echoing some sort of like base 64. Should be able to hop into look at the actual value here. Let me see. So for this one, we can actually just see like the part they're doing a wget on this URL here with logic.sh. So definitely targeting a Linux host, and they're just trying to pull down a script and pipe it into shell. A lot of these are not going to be up anymore because this activity was from a few months ago. Let me see here. Find something a little more interesting. I did want to find the one with the crypto miner. If I could find that request. Yeah, a lot of math here. Not a fan. Yeah, this one looks interesting. It almost looks like a reverse shell in Node or in JavaScript with the port. I think that's where the port would go. 12323. And like some of these IPs, we could just throw in VirusTotal. Oh, yeah. PowerShell math. Let's go 30 days. Yeah, these look like the same ones as before. Let me see if I can just, because I know it has the GitHub content in it. I do have a link, so I'm just going to pull up the link to one of the crypto miners that I was trying to find the actual web request to, but it was this, which is not going to pull up because it's the raw link. Well, that's the script they were trying to pull. I want to just grab the repo. Yeah. So there's a shell script in here to like start it up. And one of the exploit attempts I was seeing quite a couple times was to pull down that script and run this Monero Ocean. So I guess trying to set up a crypto miner. One of the interesting things is they have to pass the wallet ID as a command line argument. So you can like see their wallet ID at least. I don't know a ton about crypto, but I know Monero is supposed to be not as traceable. So I don't know if you can trace it with the wallet ID, but quite a few of those requests I saw in the honeypot. I really thought I could find where that request was, but it looks like, I don't know, maybe I lost it. One of the other interesting like exploit payloads that I saw was this here. It was in a honeypot that I turned off, so we're not going to be able to see it. But I have the line here. So let's see. Can I do? Actually, let me use Sublime Text so I can get syntax highlighting. I don't know if I have bash syntax highlighting. This will be okay, I guess. So this one was trying to pull a script cat sh from an IP. I removed the IP, but I pulled that script and there might have been a subsequent file, elf binary or something, but it ended up being this sample that I uploaded to VirusTotal. And this one was kind of interesting. So Trojan Miri Gaff Giat or something like that. Mirai. I know Mirai malware. I've heard of that one, that family before. I think it was an elf. Let me see. Yeah. So it was a script, but then it pulls down an elf based on like the architecture of the host that script determines. So that one was interesting because it wasn't just like a crypto miner. It was actually potentially a botnet or remote access tool. But yeah, so that was the majority of the exploit attempts I saw in honeypot activity. Most of them were just vulnerability scanners, which again is like gray area because you're spraying the internet with an exploit and you are technically exploiting it and executing code on that system. So don't know where that sits, but let's hop over to one of the things that I was not able to save, but I just threw it into some slides, was these POCs targeting InfoSec people. So this is becoming more and more popular because I don't know, I guess more and more people don't read the code that they run. But what happened? All right. So there was, I saw this on Twitter as it was happening. There was this repository and probably more that were React2Shell scanners. And like, I mean, the README is just totally like AI slop. And you could tell but then again, like that doesn't set off alerts right away. And the thing about this repo was that it was a real React2Shell scanner. It just was backdoored with like a couple lines of Python code. And obviously targeting security professionals that are looking to scan whatever for React2Shell vulnerable hosts of the code. So the line here, this was like at the top of the script, and looking at it, you might breeze past it because it's kind of weird looking, but if you're not used to like inspecting what hex looks like, you might, or you don't know code that well, you might just, or you don't even look at the code that you run, which, you know, that happens. The other thing about this repository that I forgot to mention was look how many stars it has. I mean, it had 47 stars and this was a day old. So, and it had 26 forks. I mean, this was definitely run by a decent amount of people. And you could see these lines here. So basically it's decoding these hex bytes and then putting them into a subprocess popen, which just runs a command shell or a command in the command shell. And and then it just runs that function right underneath. What these were decoded as was an MSHTA, like calling the MSHTA executable on Windows, and then with that URL there, PyInstaller, which is, I mean, it's just funny anyways, but no, it's not the real PyInstaller. And so what that does is MSHTA is a lol bin living off the land binary. You can execute JScript or like JavaScript for Windows hosts or VB from a URL. And at the time, this URL was already taken down, or I couldn't get the payload to download. But essentially, it's initial access vector, and if you ran this script, that's what it would do. And I just wonder like how many information security professionals were targeted with this and actually ran it and got infected from doing security research. So you really got to be careful with the stuff you're running and reading through the code. Even like command and control frameworks, like you really need to read through everything before you spin something up and you're running even Python code, even where you can read the entire script. You have to be careful. Oh, we can just pull up the lol bin here. I need to find a better way to switch screens like this. So if you go to lolbins./project, you can see MSHTA. And you can see like the different things. So it's a native built-in executable on Windows. It's at that file path. And these are the different things you could accomplish with it. So execution, you can execute a local HTA file with embedded JavaScript or VB script to execute code. You can pull in remote. You could execute inline VB script, which is interesting. Inline JavaScript, and then you can download files as well. But in this case, they were doing a remote. They were executing a remote HTA file. Yeah, Lolbin's a good resource. Looking for stuff built in native Windows binaries that you're not sure what they might be able to do or how they're used. These are all documented in MITRE tactics and all that kind of stuff. All right, we're getting close here. I got a few finishing slides. Okay. Yeah, whenever something like this happens, questions are always like, how can you protect against 0 days like React2Shell? And like the truest answer is you can't, because it's in an upstream library that you use, and there's just no way you could protect against that specific thing. But you can defend against it. So having really good detections and response in place, and yes, on Linux hosts. So if a host gets infected or popped with a remote code execution, being able to detect that post exploitation activity in one of your cloud assets is a great way to defend against a 0 day. You just need to be aware. You need to actually be collecting logs and have endpoint security on those hosts, which means you have to have a good asset inventory. So attack surface management is one of the ways you could do this. So you need to know your attack surface. If you don't, you're probably already behind. There's solutions out there. We have a solution for this. And yeah, if you don't know your attack surface, you need to know it. You need a good asset inventory. You need to know what hosts are out there, what versions of React they're running, all that kind of stuff. You need to actually be collecting logs from these hosts into a unified SIEM solution so that you can get telemetry on all of this stuff happening. And if you're not, then you don't know what's happening. And that's not good. But a lot of times that's the norm. And so, yeah, like if you're looking for services like this, we have an attack surface management service where we agentlessly collect information about your attack surface, and we look for exposures. You can do things like purple teaming. You can do assume breach scenarios where, let's say, 0 day scenario. So remote code execution on a host. How long does it take you to detect post exploitation activity, lateral movement, all that kind of stuff? Yeah, I mean, those are the type of activities that you can do to build up defenses against after exploitation happens. You can't prevent a 0 day from being exploited. There are like edge cases where you would get lucky that the exploitation of a 0 day would would cross into the telemetry of like another vulnerability exploited. So in this case, React2Shell might trigger a JavaScript prototype pollution signature because it is basically exploiting like prototype pollution. So you could get lucky. You could get lucky and your WAF could catch it. I don't think you should rely on that though, because what if it doesn't? So yeah, those are the things I just was thinking about in terms of protection. Yeah, you need to build up defenses for after exploitation happens. Playbooks, you need to know what to do and how to do it and how to use the tools that your organization uses and pays for. That's pretty much everything I had for today. Again, I don't even know if people can post into the chat here. This is the first episode of this webcast. So in the future, we're going to be also live streaming from YouTube and LinkedIn, but we just don't have that set up yet. And we're also going to post copies of this stream and the future ones to our YouTube channel. It should be like Armada Ops. And yeah, so if you miss like the rest of it, you can just go watch it on YouTube later on and we'll clip it up. And yeah, that's basically it. I see Turbo in the chat. I guess you can do comments. All right, cool. Thanks everybody. Let's see if I can figure out how to do the banner.